Okay, so today we are going to look at some of the examples from 3.5 off of CodeHS, which is our compound Boolean examples. So the compound Booleans are the ones that use the logical and, or, and nots. So let's take a look at some of those examples. But let's go ahead and just warm up first. And what I'd like you to do is answer this prompt. So imagine your final grade depended on both your attendance and your academic grade. And let's say to get an A, by the way, this is not true for this class. To get an A, you need at least 90% overall and no more than 2 absences. How would you write this in Java using a logical operator? So to remind you, your logical operators, let me go ahead and add those on the screen. So you've got and, which is basically shift and then 8. To get those, and then you've got, so that's and then you've got double pipe, which is or, and then you've got not, which is the exclamation mark. So how would you write this scenario using Java and using a logical operator? You can use whatever variable names you like that make sense. So at this point, you should switch to your Pear Deck screen and go ahead and type in the text box. Let me know if you have any questions or if you're confused. All right, so let's go ahead and look at some of your answers. Let's go ahead and share. Where is it? Show responses. There we go. Okay, so again, the question was, how would you put in Java the scenario that if you wanted to get an A, you needed at least a 90% in the class and no more than 2 absences. And so this part right here that this student put, this says that your grade needs to be greater than or equal to 90. And let's say that, yeah, you're using whole numbers for the 90%. That's totally fine. That works. And then you would use logical and to link that with the other condition. So absences has to be less than or equal to 2. So that's the same thing as saying no more than 2. So that works. And then I noticed this person added their if in there. Perfect. This works as well. Just got a little bit of a different variable name, just absent instead of absences. That works too. Let's see, what did I want to say here? Notice that it is less than or equal to, right? Because it was no more than 2, right? Something, I don't know if I saw it in your answers, but you could represent the percentage as a decimal point if you wanted to. So like instead of like a whole number 90, you could put 0.9, right? Which is the same thing as 9/10 or 90%. But this works too. All right. So let me know if you have any questions on that. We're going to get used to, oh, and I wanted to show this one too. This one, the person tried to actually put the scenarios in too. So if those were true, you got an A. Otherwise, you don't get an A. Thanks. That was a really good one. So yeah, we're going to get used to converting these basic situations into code today. That's the idea. And we'll be looking at examples of programs from CodeHS that do that for us to help us get there. So let's go ahead and move ahead to our activity. So here's our first example, and this is 3.5.4 from CodeHS. This is one of their examples. And so the idea here is that I want you all to get used to reading and tracing actual Java code. So I put the Java on the left, and then I put the flowchart on the right. And what I want you to do is I want you to try tracing this code if the user at this point on line 12, between lines 11 and 12, where the user is prompted to enter an hour of the day. If they enter a 2, what's going to happen? So I want you to annotate on this slide how you would go through this flow chart if you were the computer. So start out by writing in the value of hour, and then kind of like go down and evaluate if it's true or false, and then show me which way you would branch. I'll give you a moment to do that. All right, let's go ahead and check out what some of you thought. So let me go ahead and share some answers. So if you want to come back over to where I'm sharing my screen. Oh, that's okay, Eddie. Here, I'll just explain, and then I'll explain how this student did it. So basically what we were doing is we were taking the example program here called Number and Range from CodeHS, and we were trying to investigate what it does by tracing the code. Okay, so we can see here that on line 11, we're prompted to enter an hour of the day. Okay, so up here in yellow, we can say it gives you the scenario that the user put in too. And notice that on line 12, that input gets stored into this integer called hour. So basically what the student did was they wrote 2 to the variable hour right here on top. And then using that, we can now move into the flowchart. And notice that this flowchart has the conditional from line 18 in the example code. And that conditional is that the hour has to be greater than or equal to 0, and the hour has to be less than or equal to 24. So what this student did was they knew that they had to bring down that 2 anytime they saw the variable hour. So the conditional then became 2 is greater than or equal to 0, which is the first part of the compound conditional. It is true that 2 is bigger than 0, so they went ahead and evaluated that as true, okay. But remember, for and, both sides have to be true for the whole thing to be true, so then the student went on to evaluate the right-hand side. 2 is less than or equal to 24. That's also true. 2 is smaller than 24, so this is true as well. And then you had to remember that true and true then gets reduced to true, right? If both sides are true, the whole thing's true. So then you're going to branch this way to the true side. And what's going to happen is that the code is going to print out valid hour. So basically back at the code, the stuff that is in the if is going to happen, and then you can ignore the else. So if you didn't quite get what we were doing, it's okay. We're going to have another example actually with the same code. So now you're going to do the same thing, but let's now say that the user entered 25 when prompted for the hour of the day. So take a minute and go ahead and do basically the same thing, but with this new value. All right, so this time you were asked to trace this code given that the user entered in the value 25. Okay, so let's go ahead and take a look at one student's answer. So they went ahead and wrote 25 to hour. Okay, so that's exactly what happens on line 12 is we're storing whatever the user put in to hour. And then we have to go down and we have to evaluate this conditional on line 18. So that's what's written here. So the student went ahead and brought down the 25 anytime they saw hour. So we've got 25 is greater than or equal to 0. That's true. 25 is bigger than 0. And then we have to evaluate the right-hand side of this and. Is 25 less than or equal to 24? No, it is not. It is bigger than 24. So this side is false. So we have true and false. We know that for an and to be true, that both sides have to be true. So this is going to be false. And so we branch this way, and what gets printed out to the console is what's in the else right here. So if we look at the code on line 24, that's the code in the else block. And that's why we print out not a valid hour. Okay, so again, we're just getting used to being able to investigate and understand and trace code with the new knowledge of these compound Boolean expressions. Please let me know if you have any questions. Feel free to interrupt me on the microphone or in the chat. Okay, so I'm going to introduce one new piece of information that will be really helpful when you're tracing through code that has compound Boolean expressions. So we're going to talk about short circuit evaluations. First, we're going to talk about short circuit evaluations in the context of and, so the and operator. So recall that the only case when a compound Boolean joined with and is true is when both sides are true. So just this first row is going to result in a true. Everything else is going to be false because there's at least one false on the left-hand side of this arrow. So the moment we see a false in an and statement, we don't even have to look at the rest of the statement. And guess what? Your computer does the same thing. This is called short circuiting. They see one false in an and statement, and then they're like, oh, why am I even going to waste time to look at the rest? Because I know the whole thing's going to be false anyway, because I know that both sides have to be true for the whole thing to be true. So basically, it just ignores the rest of it as soon as they see that false. Okay, as soon as they see that false in the context of an and. Remember, this is just for and. We can also do the same thing with an or statement, but it's a little bit different. Let me know if I'm going too fast, by the way. So short circuit evaluations for or depends on the fact that both sides of an or statement have to be false for the whole thing to be false. Okay, we remember that. As soon as we see just one true in an or statement, we know the whole thing's true. Therefore, it's kind of the same. The moment we see a true in the case of an or, we don't even have to look at the rest of the statement because we know the whole thing's going to be true. So we use short circuiting for or statements anytime we see a true. So we see a true, we're not even going to bother looking at the rest because we're going to know the whole thing is true. And again, the computer does this too. So when you're tracing through these programs and you're evaluating an or statement and the first thing is true, you don't even have to bother looking at the rest. You could just exit out if you want. Okay, so we're going to use that knowledge, that new knowledge, to take a look at another example here called pizza slices. Okay, so look at this program, take a moment and see what's going on. Notice that on line 28, we have num slices, so that's the number of pizza slices, and it's just set to 10 for us. And then we want to actually ask the user on line 30 how many people are going to be eating pizza. And that answer is stored inside of num people. Okay, and then we have to evaluate if we have enough slices for each person. So what I want you to do is I want you to evaluate the scenario that the user enters in 0 for num people. And I want you to then trace through this this flowchart and tell me what's going to happen. Is it going to be true or is it going to be false? So again, you're using the value 0 for num people. So go ahead and switch to your Pear Deck slide and annotate and decide what happens. All right, I'd like to take a look at one person's answer. So let's go ahead and come back to the screen where you're looking at my screen. Okay, so this person wrote in 0 for num people, as we mentioned, and then brought down 0 over here. And let's see what happens here. So let me highlight this portion of it. So this is the first part of our compound Boolean expression. We're asking, is the number of people not equal to 0? And guess what? Number of people is 0. So 0 not equal to 0, that's going to be false, right? We're asking, is 0 not 0? 0 is 0. So this whole thing's going to be false. And what we just learned is if we see a false in an and statement, we don't even have to worry about looking at the rest. We can cross this out. We don't even have to look at this. We don't have to worry about it. So we can conclude that we go to the right and get false, and that what's going to get printed out is that there's not enough pizza for everyone. I'm going to show you why this is a good thing that we short-circuited. If we didn't short circuit, let me erase this. If we continued to evaluate the system, this statement, let's see what would happen. We would have to evaluate this side. And so in order to evaluate that side, we would have to bring down the value of num slices, which is 10. And then bring down the value of num people, which is 0. And so basically we would have to be dividing 10 by 0. And that's undefined, right? Dividing something by 0 is undefined. So on a computer, it's just going to have a runtime error. It's going to crash. So that's why it's a good thing that we short circuit, that we don't even bother evaluating this right-hand side. Otherwise, our code would crash. So it doesn't actually get here, thankfully. Instead, it sees this first false, knows that as soon as you see one false in an and statement, that it doesn't matter what this is, so it doesn't even look at this. And it just automatically says, okay, it's false. And then it goes down here and prints out that there's not enough pizza for everyone. Please let me know if you have any questions about that. So again, this process is called short circuiting. All right. So the last thing that we're going to do is here is the first homework exercise on CodeHS. This is 3.5.6. It's actually linked at the top here if you want to open it. I went ahead and I put the actual homework description here. So they want you to write a program that determines if a user can ride a roller coaster. To ride a roller coaster, you have to be at least 42 inches tall, and you have to be at least 9 years old. So in this program, you're basically going to ask the user to input how tall they are and how old they are. You're going to store those to variables, and then you're going to use a nested if statement to determine if they can ride the roller coaster. So how would you implement that? How would you map that out in just a flow chart here? So this is kind of like writing a outline for an essay. We are writing kind of like an outline for our code. So this is the last thing we'll do, and then what we'll do is when we come back, we'll actually write out the code for this as well. And I just noticed they said nested if, but I want you to use a compound. So I want you to use a compound Boolean expression. I don't want you to do a nested if. I want you to do a compound. So let's see, we have about 2 minutes left. So I'm going to give you maybe a minute and then we'll try to speed it up and take a look. It looks like some of you are quite fast. You guys are getting it. That's good. All right. Yeah, we only have a minute left. So I'm going to go ahead and show what one person came up with. Okay. So the decision is whether or not someone can ride the roller coaster, right? That's what you would write up here. And then down here, the two variables this person came up with was height and age. Short and sweet and also meaningful. Great. Awesome. And then down here for the compound conditional, they came up with that the height has to be greater than or equal to 42. That's the same thing as at least 42 inches. Great. And the age has to be greater than or equal to 9. So again, they have to be at least 9 years old. So that's the same thing there. Awesome. If this turns out to be true, then they can ride the roller coaster. So what gets printed out is welcome aboard. That's what was written here. And if any part of this is false, then it's going to print out, sorry, you are not eligible to ride. Okay, so on Wednesday, we are going to talk about how to take this flowchart and convert it to Java code. So if you want, I'm going to actually take a screenshot of this. I'll go ahead and post it to Google Classroom. And if you want to try doing this before a class on Wednesday, that would be awesome. Maybe someone could share their screen if they come up with a solution. And then we'll go through the rest of the exercises together as well next class. So at least try 3.5.6. And if you have time, attempt the remaining exercises too and bring questions about those. But at least try that first one. All right, so I know that some of you have class at 10:40, so if that's you, you can go ahead and take off. If not, if you want to give some feedback about this lesson, feel free to stick around for a couple minutes and write your answers on this last Pear Deck screen. But yeah, if you have class, feel free to go. I don't want to make you late for your other class.